Although wheels and tires were somewhat of an afterthought on most early aircraft, today's sophisticated flying machines must be able to depend on well-designed tires to assure safe takeoffs, landings, and dependable ground operations. This program on aircraft tires and tubes has been prepared to help the technician understand the principles of good tire and tube maintenance. During this program, we will discuss tire construction, inspection and removal, tubes, and mounting and balancing. Goodyear tires will be identified by size, ply rating, speed rating, load rating, whether they are tubeless or require a tube, the mold skid depth, the tire serial number, part number, and the TSO certification showing that the tire complies with the latest requirements. The Type 3 tire is the most popular low-pressure tire found on today's piston-powered aircraft. The section width and rim diameter are used to designate the size of the tire. For example, a tire having a section width of 9.5 inches and fitting a 16-inch wheel would be identified as a 950/16 tire. This is a Type 4 extra low pressure tire. It is used for rough and unimproved fields. These tires are obsolete, but still may be found on some older aircraft in rough or bush operations. Their size designation includes the outside diameter, section width, and rim diameter. The Type 6 tire is a special low-profile tire designed for nose wheel applications. Its lower section height reduces the amount of wheel drop if the tire is completely deflated. The size of these tires is designated by their outside diameter, section width, and rim diameter. Extra high-pressure Type 7 tires are used by jet aircraft. They have an exceptionally high load-carrying ability and range in ply ratings from 4 to 38. The tire sizes are designated by their outside diameter and section width. The Type 8 tire is used for military jet aircraft. With their extremely high takeoff speeds, extra high pressures, and low profiles, these tires are designated by outside diameter, section width, and rim diameter. Tires that are presently being designed will be classified with a letter type and designated by their outside diameter, section width, and bead seat diameter. In the past, tires were rated for strength, so today's tires are given a ply rating to identify the tire's maximum load-carrying capacity and inflation pressure for a particular service application. Aircraft tires are manufactured both as tube type and tubeless. Tubeless tires are identified by the word tubeless on their sidewall. Tube type tires are not identified. Aircraft tires must be constructed strong enough to absorb the tremendous loads of touchdown and operate at very high speeds for a relatively short period of time. The most important part of the tire is the bead. It anchors the carcass and provides firm mounting for the tire on the wheel. Ultimately, all of the forces on the tire terminate at the bead. The beads are made of bundles of high-strength carbon steel wire, with 1, 2, or 3 of these bundles used in each side of the tire. The carcass of the tire is made up of layers or plies of rubber-coated nylon cord fabric. These strips extend completely across the tire and lap back over the beads to form the ply turn-ups. Each successive ply is put on such that the cords cross each other at about 90 degrees, so the strength of the carcass will be balanced. The tread is the wearing surface of the outer circumference of the tire. It is made of specially compounded rubber and has a pattern of grooves molded into its surface to give the required traction characteristics. The most popular tread pattern found on aircraft today is the rib tread. It is designed especially for use on hard surface runways and gives long tread wear, good traction, and and exceptionally good directional stability. Jet aircraft with aft-mounted engines have a problem with water and slush being thrown up by the nose wheel and entering the engine, causing damage or flame out. To prevent this, the nose tires on these aircraft have keens or deflectors to direct the water away from the engine intakes. The sidewall is a rubber covering that joins with and extends from the tread down around the bead to protect the carcass from injury and exposure to moisture and ozone. Proper tire inspection and removal will help get the full service life from the tires on any aircraft. Tire inflation pressure is critical. Ideally, inflation pressure should be checked daily and before each flight. Overinflation causes accelerated centerline wear of the tread while leaving rubber on the shoulder. When a tire is worn this way, it has much less resistance to skidding than it would have if its tread wears uniformly. While overinflation is bad, underinflation is even worse. Underinflation causes excess heat to be generated within the tire. Tires that have been operated with low inflation pressure will have their tread worn away more on the shoulders than in the center, and any tire showing this pattern of wear should be carefully examined for evidence of hidden damage. The pressure specified in the airframe manufacturer's maintenance manual is for the loaded tire, that is for the tire supporting the weight of the aircraft. Inaccurate pressure gauges are one of the major causes of inflation problems. The best gauges for this purpose are the dial-type indicators, since they are less subject to careless handling and are easier to read in the small increments needed to accurately determine the tire pressure. Inflation pressure should always be measured when the tire is cold, so allow 2 or 3 hours to elapse after a flight before measuring tire pressure. A tire that has been properly maintained and operated with the correct inflation pressure will wear the tread uniformly and should be removed from the aircraft while there is at least 1/32 of an inch of tread remaining. This procedure will prevent reduced traction caused by smooth tires and allow the worn tire to be suitable for retreading. When it has been determined that a tire must be removed, jack up the airplane according to the procedure outlined in the manufacturer's maintenance manual. When the weight is off the tire, deflate it using a deflator cap. The high pressure in some aircraft tires could eject the valve core with enough velocity to injure anyone it should hit. After all the air is out, you can safely remove the valve core. Remove the wheel following the aircraft manufacturer's service instructions. Be sure that the bearings are protected from damage and are stored in a safe place until they can be cleaned, inspected, and repacked with the proper grease. Place the wheel on a flat surface and break the bead away from the wheel. Use a straight push as near to the rim as possible. Never use any kind of tool to pry the bead from the tire. This practice could cause serious damage to the wheel or tire. When the bead has been broken from both sides of the wheel, remove the wheel bolts and lift one wheel half from the other. You may now remove the tire. If the tire is a tubeless type, be careful that the O-ring seal between the wheel halves is not damaged. With the tire removed, inspect it carefully for damage. All areas of the tire should be checked, including the bead, inner liner, sidewalls, and tread area. Aircraft tires are highly stressed, and damage such as this flat spot condition is cause for immediate removal. If you know what constitutes a non-repairable condition, such as this tire, time and money can be saved by discarding the tire without first sending it to the retread agency. A note of caution is that no repair should be attempted by anyone not adequately equipped and approved for this work. Normal tire use will wear away the tread long before the carcass is worn out. so it is standard practice for aircraft tires to be retreaded. Retread tires are identified as such. A great number of aircraft tires incorporate the use of an inner tube. It is important to know how to deal with a tube to assure maximum service life and safe operation. All aircraft tubes are made of a specially compounded rubber that retains air with a minimum of leakage. So there are really only two reasons that a tube should leak: a hole in the tube or a defective valve. If a tube is suspected of leaking, first check the valve by spreading a drop of water over the end of the valve. If a bubble forms, the valve core should be replaced. If no bubble appears, the tube should be checked for leaks. To find a leak in the tube, inflate it and submerge it in water, looking for the source of the bubbles. Do not put more air in the tube than is required to round it out. Too much air may damage the tube. Inspect tubes carefully around the valve stem and valve pad for any indication of the pad pulling away from the tube. Examine the inside circumference of the tube for any evidence of chafing by the toe of the bead or by corroded wheels. Any tube that is chafed enough that it has lost some of its thickness in spots should be replaced. Repairing aircraft tubes is not recommended. New tubes should be installed to replace damaged ones. Tubes should also be replaced when new tires are installed. Tubes should never be stored by hanging them over nails or pegs, or any way that would cause a sharp fold or crease. Tubes with creases should not be put into service. Keeping them in the original factory package until ready for use will assure proper storage. After proper inspection of the tire and tube and cleaning of the wheel, the parts are ready to be assembled. Proper mounting and balancing will assure good service from the wheel assembly. The wheel is a highly stressed component of the aircraft, and it is extremely important that the manufacturer's service information be followed in detail. This includes such items as bolt torque, lubrication requirements, and wheel balancing points. Before the tire is mounted, the wheel must first be carefully inspected to be sure that there are no nicks or scratches in the bead seat area that could cause an air leak. The area on which the O-ring of a tubeless tire seats should be checked to be sure that there is no damage that would prevent the O-ring from making an airtight seal. Check the condition of the thermal fuse plugs if they are used. And clean the bead seat area and the O-ring groove with a cloth dampened with isopropyl alcohol. Check to be sure that the tire is approved for the aircraft and that it is proper for the wheel in use. Lubricate the O-ring with the same grease that is used for the wheel bearings and carefully place the seal in the groove without stretching or twisting it. Place the outboard wheel half in the tire in such a position that the red balance dot on the tire is aligned with the valve on the wheel, and align the bolt holes. The torque on all of the wheel bolts is highly critical, and many of them require an anti-seize compound, such as lube torque, applied before installation. Consult the maintenance manual for proper procedure. Tighten the nuts uniformly in a crisscross manner to approximately 1/2 of the recommended torque. Then repeat the procedure and tighten them to their full recommended torque. One word of caution, however, never use an impact wrench to torque wheel bolts. Since the torque produced by an impact wrench is in a series of blows or jerks, the spikes of torque will stress the fasteners more than they are designed to endure. Use only a hand torque wrench of known accuracy, which has been recently calibrated. Tire inflation should be accomplished in an inflation cage. Inflate the tire just enough to seat the bead. After you are sure that it is seated uniformly, inflate it to the recommended pressure. After a 12-hour stretch period, reinflate to rated inflation pressure. It is important to make an air retention check after the next 24 hours. If the tire pressure is dropped more than 5%, you should check for a loose or defective valve, valve core, or seal. If none of these conditions are discovered, the tire must be disassembled and checked for incorrect assembly or damage. Before mounting a tube-type tire, be sure that the tire and tube are the correct ones for the installation. Use of the wrong tube could result in failure of the tube. Before mounting the tire, clean the bead seat area with a cloth dampened with isopropyl alcohol. Check the inside of the tire to be sure that it is clean and free of all foreign matter. Then dust it with an approved tire talcum. Fold the inner tube and dust it with talc. Slip it inside the tire with the valve sticking out on the side of the tire having the serial number. Inflate the tube just enough to round it out and adjust it inside the tire so that the yellow mark indicating the heavy point of the tube aligns with the red dot on the tire that indicates its light point. If there is no balance mark on the tube, you can assume that the valve is the heavy point. Install the tire and tube on the outboard wheel half so that the valve stem sticks out through the hole in the wheel. Now you can place the inboard half of the wheel in the tire. Be sure that you do not pinch the tube. Install and torque the bolts in the same manner as a tubeless tire. Put the tire in a safety cage and adjust the inline air pressure to the manufacturer's recommended tire pressure. Use a clip-on air chuck and inflate the tire gradually to the recommended pressure to seat the bead, then completely deflate it. Now reinflate the tire to the recommended pressure. This inflate, deflate, inflate procedure will help the tube equalize itself in the tire, and all of the wrinkles will be straightened out. There are two reasons why the inflation pressure of a tube-type tire may decrease after it is first installed. First, the nylon plies will stretch the same as in a tubeless tire. The second is air may be trapped between the tube and the tire, reducing the volume of the tube. When this air leaks out, the inflation pressure will drop. Check the inflation pressure after 24 hours. If there has been more than a 5% drop in pressure, check the valve core for leakage. If that is okay, disassemble the tire and check the tube for leaks. As aircraft takeoff speeds have increased, the vibration caused by unbalanced wheel and tire assemblies has become annoying. This is especially noticeable on nose gear assemblies. The Goodyear Tire and Rubber Company has developed a compact balancer that may be found in many general aviation shops. To begin the balancing process, remove the bearing cones from the wheel and center the inflated tire and wheel assembly between the cones of the balancer unit and tighten the cones. Tighten the balancer disc against the sidewall of the tire, or in some cases against the cone of the balancing shaft. Be sure that the scribed area of the disc is on the outside where it can be seen. Place the shaft with the tire and wheel installed on the uprights of the balancing stand, with the bearings centered in the uprights so that the shaft can rotate freely. Allow the heavy spot on the wheel and tire assembly to settle to the bottom, which is the 6 o'clock position. Put a mark at the 12 o'clock position to mark the light spot. Move the locator disc around until the scribed centerline mark is lined up with the mark indicating the light spot. Using the locator disc as a guide, mark the weight locations on the sidewall of the tire. These marks will be about 45 degrees either side of the light spot. Counterbalance the heavy spot of the wheel and tire assembly By applying the magnetic test weights on the balancer disc at the proper rim diameter scribe for the wheel or tire assembly being balanced. Balance weights that each equal the magnetic test weight should be installed in line with the marks you made either side of the light spot. Some balance weights are installed on special brackets that mount under the head of the wheel bolts, and others fastened to the wheel rim by a cotter pin through holes that have been drilled in the rim for this purpose. Many smaller wheels do not have provisions for mechanically attaching the balance weights. For these wheels, lead strips having an adhesive backing may be used. Use only the type of balance weight approved for the wheel you are balancing. If you find that the weight in ounces required to balance the wheel exceeds the rim diameter in inches, you should deflate the tire, demount it, and check to be sure that all of the required permanent balance weights, if needed, are installed. If everything is okay, turn the tire 90 degrees on the wheel, remount, and repeat the balancing procedure. A properly maintained tire and wheel assembly will perform with a high degree of reliability through many takeoffs and landings. This training program on aircraft tires and tubes has been prepared to help you more efficiently service these vital components. As with all aircraft systems, rely on the service information provided by the aircraft manufacturer for the most up-to-date procedures and specifications.